Hello dear student, welcome to my YouTube channel. In this video we will see how to calculate a factor for any assay. So here we will see an example of an ammonium chloride, which is acid-base assay. As per your syllabus you are having this ammonium chloride assay. For factor calculation, first thing is that you should know the reaction. So let us see the reaction for assay of ammonium chloride. See, the reaction is ammonium chloride. It reacts with formaldehyde and it produces methylenamine. So along with methylenamine, it produces one more important compound, that is acid. So this is methylenamine and this is acid. Now further the acid which has been formed in this reaction, so it has been titrated with a known volume of an NaOH. So this will be the further reaction, that NaCl plus H2O. So this is the overall reaction, that ammonium chloride, it is reacting with an formaldehyde and it forms a methylenamine. And important thing here, HCl which has been formed, so that concentration of an HCl which has been determined with the help of known concentration of an NaOH. So in the burette you will have this NaOH and remaining part that will be in the conical flask, means ammonium chloride, that will react with the formaldehyde which will produce methylenamine plus HCl, and so that HCl, it will be titrated with an NaOH and then it will form a salt, that is sodium chloride and water. If we see over here overall reaction, it means that what actually we are performing an assay of an ammonium chloride using a titrant, that is NaOH. So we can write this NH4Cl, it is equivalent to NaOH. It means that there are one mole, means there is only 1 mole. You can see this reaction is naturally it is balanced, so there is no need to balance this reaction. So 1 mole of NH4Cl, it is equivalent to 1 mole of NaOH. 1 mole means what? So I will write here, so that is 1 mole. 1 mole of this NH4Cl and 1 mole of NaOH. So 1 mole of NH4Cl and 1 mole of NaOH. So for that purpose we have to calculate a molecular weight. So molecular weight of this sodium hydroxide 23. See this 23, it is of sodium, hydrogen it is 16 and oxygen 1. So totally it is 40 gram of NaOH, 40 gram of NaOH. And for ammonium chloride, so for nitrogen molecular weight, it is almost 53.49 grams. So 53.49 grams of an ammonium chloride, it is equivalent to 40 grams of an NaOH. Means what? 40 gram of NaOH can neutralize this much amount of an quantity. Now for the further factor calculation, see for factor calculation I have to convert this 40 gram of an NaOH, so I have to convert in the concept of an molarity. So molarity is like, the concept of molarity is like 40 gram, when we add 40 gram in 1000 ml solvent, and it will give 1 molar NaOH solution. So that can be also written, I will write exactly opposite to it now. So here I will write 1 molar NaOH, 1 molar NaOH, and so it is 1000 ml, 1 molar NaOH 1000 ml, it means it is a 40 gram. When we come to a concept of a molarity, 40 gram NaOH means it is 1 molar solution in 1000 ml, so that is 40 gram of NaOH we require for it, and it will neutralize 53.49 gram of ammonium chloride. So this is an overall reaction. From this overall reaction we have calculated a factor, but we have calculated factor for 1000 ml. So cross multiply it and we have to calculate a factor for 1 ml, means each ml. So you might be knowing that when we calculate a factor, we require it So this factor it is for 1000 ml of an NaOH. So 1000 ml it will neutralize 53.49 gram of an ammonium chloride. So I want to calculate for 1 ml. So cross multiply it. So after cross multiplying, consider this x. So x will go and multiply with 1000. So 1000 will come down. 1 it will be multiplied with 53. So multiplication with an 53 1. So directly either you can you can remove this decimal point and you can directly calculate. Now the decimals are, see there are 3 zeros, means what we have to do. So take this 0.053. So take this decimal by 3 digit and 53.49 gram of ammonium chloride. So this is calculated for each ml. So each ml of 1 molar NaOH, and as per the procedure, so this is not an 1 molar solution, it is 0.1 molar solution. So for that purpose again shift the decimal. So it will be like, you can again make a cross multiplication. So for 1 ml 1 molar it is like 0.05349 gram. So what should be for 0.1, or either you can make a direct calculation, like if I am here writing 1 molar NaOH, so you can shift this decimal. So so this it will shift, there will be one more 0. So 0.05349 gram of ammonium chloride, and here you can write each ml of 0.1 molar NaOH. So each ml means 1 ml of an NaOH, it will neutralize this much gram of an ammonium chloride. So this is how you can calculate a factor and you can utilize for an assay calculation. So thank you for watching the videos. Stay tuned with my channel for more videos.